Hello, in this section we're going to be learning about derivatives of inverse functions, and so we're going to start this off with talking about calculating the derivative of an inverse function, and then we're going to relate it over to the next part into trig functions. It's pretty interesting. So our learning outcome: calculate the derivative of an inverse function. Now so we have the principle that f inverse prime, the derivative of the inverse function at some point, is 1 over f prime of f inverse of a, and we can extend that to give us the overall formula to find the derivative of the inverse function, which is here. So the way to read this is the derivative of the inverse function of x is 1 over the derivative of the original function evaluated at the inverse. So to find the derivative of the inverse, you can do 1 divided by the derivative of the original function evaluated at the inverse. That is the composite function there. So if your derivative is too hard to calculate, you can do it this way. And we're going to use this technique both to help us expand our current knowledge of the power rule, as well as in the next part we'll use it to help develop the derivatives of the inverse trig functions. Okay, so there's a rule, and let me just go read it here. So let f of x be a function that is both invertible, that's key, and differentiable. Let y equals f inverse of x be the inverse of f of x for all x satisfying f prime, that's the derivative of f inverse of x not equal to 0, because that's going to be in the denominator. The derivative, so the derivative of y with respect to x, where y was the inverse of f, is d dx of f inverse of x, or f inverse prime of x, which is 1 over f prime of f inverse of x. Now the notation that we're going to be using, that the book uses quite a bit, is this g of x is the inverse of f of x. So the derivative of g is going to be 1 over f prime of g of x. And what I want to stress is that the relationship that you're going to see come up quite a bit here is that f is the inverse of g. G is the inverse of f. So as we go forward. So this first one says use the inverse function theorem to find the derivative of g of x equals x plus 2 over x. Compare the resulting derivative to that obtained by the differentiating the function directly. So I'm going to scoot this over here a little bit. Now, what is important is to remember how to do an inverse function, and my concern is that many people tend to forget that after they learn it in their Math 126 days. So I'm going to go through it once here to derive the inverse function, but down the road in the future problems, for time's sake, I'm going to skip that. So we have g of x equals x plus 2 over x. And in doing the inverse, we can write y equals x plus 2 over x. And then the way I've always taught this and been doing it, I'm going to swap x and y so that we have x equals y plus 2 over y, and then solve for y. So that means we'd have x equals y plus 2 over y, multiply both sides by y, xy equals y plus 2, and then subtracting 2 from both sides. No. Need to subtract y from both sides. We would have xy minus y equals 2. Factor out the y, so y times x minus 1 equals 2. So y equals 2 over x minus 1. And for the sake of being convenient here, I mean, that's our g inverse of x, but we can call that our f of x too. Excuse me. So now what we're after is g, the derivative of g, so our g prime of x is going to be, I'm just using the formula from above, 1 over f prime of g of x. So if that's our f, we need f prime of x is going to be, well, let's think about this. I'm just going to make this easier on ourselves. So f of x is 2 over x minus 1. Excuse me. F prime of x is 2 times x minus 1 to the negative 1. So as you learn by the chain rule, or just, sorry, that's just still f of x. So our f prime of x is going to be 2 times negative 1 times x minus 1 to the negative 2 power, or negative 2 over x minus 1 squared. Okay, fun. So we're looking for this g prime of 1 over f prime of g of x. So we think about what is our g of x, and we're going to put that in here. So our f prime of g of x is going to be negative 2 over g of x minus 1 squared. So that's going to be what? Negative 2 over, and our g of x was originally x plus 2 over x. So it's x plus 2 over x minus 1 squared. So negative 2 over, that's x plus 2, and to subtract 1, I have to make it x over x, so minus x over all over x. So it's negative 2 over 2 over x. So that's going to be negative 2 times the reciprocal of 2 over x. So it's x over 2. So I get negative x. I seem to have dropped a square back here, so let me just back up a little bit. So this was squared. So it's going to be negative 2 over 2 over x squared. So that's going to be negative 2 over 4 over x. So it's going to be negative 2 times, oh, that's squared. Yeah, I don't like my squares today. Negative 2 times x squared over 4. So it looks like we have negative x squared over 2. Reduce that down. So that is f prime of g of x. We're not finished at all. We got a little more to do. So just recall that our g prime of x is 1 over f prime of g of x. And we just found f prime of g of x. So this is 1 over negative of x squared over 2, which would be negative 2 over x squared. Okay, now that's the long way. The short way, and I really am stressing here, by the way, I'm trying to follow the notation that they used, and that's why I'm calling f the inverse of the g, and they're asking us to find g prime. And we have the tools already. We have that g of x was x, or was it x minus, there's x plus 2, excuse me, over x. And if we do g prime of x using the quotient rule, it'd be low, which is x, d high, which is 1, minus high, which is x plus 2, d low, which is 1, over x squared. So this gives us x minus 2 over x squared, or negative 2 over x squared. And my reason for doing that, and the reason they wanted us to do it this way, even though we could do this much quicker doing the regular quotient rule, is that they wanted us to give us some confidence in what this function does and what this process does. So we went from having this, that's the same as having this. Okay, so I hope that makes some sense, and you can trust that this will help us yield the results we're after. Okay, let's go on to another one here. Use the inverse trig function. Get my color back to blue. Theorem, inverse function theorem to find the derivative of g of x equals 1 over x plus 2. Compare the result obtained by differentiating g of x directly. And if you want to do that, our g prime of x is going to be, I would almost treat this as our g of x being x plus 2 to the negative 1. So g prime of x is going to be negative 1 times x plus 2 to the negative 2. Or negative 1 over x plus 2 squared. That's how I do it. But they want us to do this other way. So we have to find so for our g of x, so that's that way. G of x is our 1 over x plus 2. And our g inverse, and I'm not going to derive it this time. I'm really hoping that knowledge just stuck with you. You remember how to do it now. Our g inverse, which we're going to call f of x, is going to be 1 over x minus 2. So we look at f prime of x, because that's part of the process. We're looking for g prime of x is going to be 1 over f prime of x, f prime of g of x. So our f prime of x is going to be, can I just state it, or that's going to be, I guess if I need to say it this way, x to the negative 1 minus 2. So it'll be negative 1 times x to the negative 2 minus 0, because the derivative of 2 is 0. So that's going to be negative 1 over x squared. So if we look for f prime of g of x, we're looking for negative 1 over g of x squared, which is going to be negative 1 over x plus 2 squared. So that's going to be negative 1 over x plus 2 squared, which becomes negative 1 times x plus 2 squared over 1. So it's negative of x plus 2 squared. So that's our f prime of g of x. So our g prime of x, just to restate the whole thing again, is 1 over f prime of g of x. So that's going to be 1 over this negative of x plus 2 squared, which is negative 1 over x plus 2 squared, quantity squared. And that is the same thing as if we just took the direct derivative there. So these are very much related. Okay, let's move on a little bit. Remember, you can always pause these. Use the inverse function theorem to find the derivative of g of x equals the cube root of x. So for that, again, if we're going to find the inverse function, I'm hoping you see the inverse function for this one. But our g inverse of x, which we're going to call f of x, is going to be x cubed. Again, we're looking for g prime of x is 1 over f prime of g of x. So what is our f prime of x? That's going to be 3x squared, right? So f of g of x is going to be 3 times g of x squared, which is 3 times the cube root of x squared, or 3 times x to the 2/3 power. So our g prime of x is 1 over f prime of g of x. We just found f prime of g of x. So that's 1 over 3 times x to the 2/3. And we can write that as 1/3 of x to the negative 2/3. Okay. And we have a similar one here, which is doing the 5th root. So if we say g of x equals the 5th root of x, then our inverse function, our g inverse of x, which is what we're going to call f of x, is going to be x to the 5th power. So our f prime of x, man, that got real sloppy, is going to be 5x to the 4th power. And we're looking for f prime of the original g of x, which is going to be 5 times g of x to the 4th power, which is 5 times the 5th root of x to the 4th power. And it might be helpful to see this as 5 times x to the 4/5 power. So if we're looking for g prime of x, that's going to be 1 over f, remember f's the inverse, f prime of g of x. We just found f prime of g of x, that's 1 over 5 times x to the 4/5, which is 1/5 x to the negative 4/5 power. So with that, we get to, I hope we see a pattern that's been developing. We've taken the derivatives of power functions before, but they've always been integers. And now we're looking at these as having, like this g of x, you could see this as x to the 1/5. I'm in the dead spot of the screen. X to the 1/5. And notice the derivative is 1/5 x to the negative 4/5. In the previous problem, we had our g of x was x to the 1/3, and the derivative was 1/3 x to the negative 2/3. So if you notice the pattern that's going on here, great. If not, I'll tell it to you. So when you take the derivative of a function, a power function with a rational power, you bring that power out front and subtract 1 from the power, just like you do for having integer powers. And if it's dx of x to the m over n, you bring that power out front, m over n, x to the m over n minus 1. That's it. Okay. There's a fun-filled proof for you to peruse if you like. So find the equation of the line tangent to the graph of y equals x to the 2/3 at x equals 8. So now we can use the rule. We don't have to go through this whole process again. And our y prime is going to be 2/3 x to the 2/3 minus 1. So it's going to be 2/3 x to the negative 1/3. By the way, y equals 8 to the 2/3 is going to be, the cube root of 8 is 2, 2 cubed is 2 squared is 4. So it has the point 8, 4. Our slope, y prime, is going to be 2/3 times 8 to the negative 1/3. So that's going to be 2/3 times 1 over 2 is a negative power. 2's divide out, it's 1/3. So y minus the 4 equals 1/3 times x minus the 8. So y minus 4 equals 1/3 x minus 8/3. Then if we add 4 to both sides, remember 4 in terms of thirds is 12/3, so that's y equals 1/3 x plus a negative 8/3 plus 12/3 is 4/3. Got a couple more here. Find the derivative of s of t equals the square root of t, 2t plus 1. So I'm going to call this s of t equals 2t plus 1 to the 1/2 power. So s prime of t is 1/2 times 2t plus 1 to the negative 1/2 times the derivative of what's inside, so that's just going to be 2. So the way I see it, this 1/2 and this 2 will divide out. So we have s prime of t equals 1 over the square root of 2t minus 1. And I think, is this the last problem of this part? There's another part to this section. Then we'll do inverse trig functions, but this is the last one here. So we're looking at f of x equals the square root of 2x squared plus 4x plus 7. So I'm going to rewrite this as 2x squared plus 4x plus 7 all to the 1/2 power, so that our f prime of x will be 1/2 times the 2x squared plus 4x plus 7 to the negative 1/2, 1/2 minus 1 is negative 1/2, times the derivative of what's inside, so that's a 4x plus 4. So our f prime of x is going to be the 4x plus 4 over 2 from the 1/2 times the square root of the 2x squared plus 4x plus 7. And we can reduce the 2 out of the numerator and denominator, so it's going to be 2x plus 2 over the square root of 2x squared plus 4x plus 7. And then they ask us for f prime at 2. Is that right? Yeah. F prime at 2 is going to be 2 times 2 plus 2 over the square root of 2 times 2 squared plus 4 times 2 plus 7. And I come up with 6 over the square root of 23. Let me know if you get something different. Okay, that does it for this part.